trig equations. Y equals to sine x equals to half, or I simply say sine x equals to half, where x belongs to 0 to 4 pi. I need to find all the values of x where sine x is half in the domain 0 to 4 pi. That's the goal, right? Now, there are few ways of doing it, but let's understand, my way of it, which is, I find it to be an easier one. Then if you've got better versions, we can talk about it. I want you to listen to what I'm teaching, and in the meantime, if you can quickly go and check alongside, as I'm speaking and explaining, can you just quickly grab from your exact value table that when is sine x half? What pi value? Just keep it with you. I will need it. And I'm going to ask it, right? What value of x, what value of sine gives me half, right? So I'm gonna need that. Now, 0 to 4 pi, my function is sine x, y equals to sine x. So y equals to sine x. What is my period? Period n value is 1. So the period is 2 pi over 1, which is 2 pi. That means one full round gives me 2 pi, my period. Or another way of looking at it is one wave gives me 2 pi. One and the same thing, right? Now, listen to what I'm just trying to make you learn. Now, I need the sine value to be a positive value, a positive half, right or wrong? I need to see your nods, right? A positive half. My fourth quadrant, my ASTC tells me, where is sine half positive? Forget about the half. Where is sine positive? Second quadrant and first quadrant, right or wrong? So step 1 is identify quadrants based on the question. In this scenario, my quadrants identified are first and second. If in case this would have been a negative half, for example, then my quadrants would have changed. Then I would have asked a question to myself, where is sine a negative value? Then the answer would have been third and fourth quadrant. Am I right? I need to see a nod. But I'm after a positive value. So my first step is identify quadrant. So which means first quadrant and second quadrant. My second step, step 2, is find the reference angle, which means find the reference angle means the first quadrant angle with respect to the value that I am given. So I need to find that what value of x will be half in the first quadrant. Always, not just because I've identified first quadrant as one of my quadrants, irrespective. I need to know the first quadrant, the reference angle value. So can someone tell me which value of pi, which value of x, pi by 3 or pi by 6, one of the two should give me a half for sine? What would that be? Can someone unmute and tell me?
Pi by 6.
Okay, cool. Pi by 6 is my reference angle. Now I come back to the quadrants that I've identified, the step 1. And here is the step 3. Go back to step 1 and change the reference angle as per the quadrants identified. When I said quadrants identified, I told you in my previous session, first quadrant value is theta, second quadrant value is pi minus theta, third value is pi plus theta, and this is for an anti-clockwise rotation, and this is 2 pi minus theta. What quadrants have I identified? 1. So it is theta. In this case, my theta is the x. So I will simply replace it by x. And the second quadrant is pi minus theta, which means pi minus x. What is x? X is the reference angle, which you have identified as a part of step 2. So in step 3, you convert this reference angle that you found as per the quadrants that you have identified. So in this scenario, though the reference angle is always the first quadrant, but by chance, the quadrant identified is also one of the one is first quadrant. It happens to be the same. So my x, which means pi on 6, and pi minus pi on 6 is 5 pi on 6. So I have two solutions right in front of my eyes. What it essentially means is if I just sort of now take this down. So what I've done is that on the unit circle, when I'm moving anti-clockwise, I was interested in the first quadrant and the second quadrant because of the step 2. I found pi by 6 as my first value, which is here. And my second value is here, which is pi minus pi by 6 or 5 pi by 6. Is that okay? So far, so good? Thinking in? All right. Now, I started at this one. I'll slightly change the color now. I started here and I found my first solution. Cool. This is my first rotation. I'm going from 0 to 2 pi. I came here. Oh, I found my second. Awesome. While I'm doing my first rotation, I found my two solutions. Cool. And I ran it at origin back. I completed 2 pi's. What is my domain? My domain was 0 to 4 pi. That means I'm allowed. I now have to do another rotation because I'm just done 2 pi's. I'm allowed to go one full circle again. So I start from this point again. And hang on. I reached at the same spot again. So how much have I rotated from this point to arrive back at the same point? One full circle. 2 pi's. While my initial solution was pi by 6 and 5 pi by 6, that was my first rotation. In the second rotation, I again landed at the same spot in the same quadrant. But how much have I rotated from my initial point? One full period of my function, 2 pi. Keep moving. Hang on. I've reached here again. If I started from this point and I've gone back and come back again, what have I done? I've done another 2 pi's with reference to this point. And then I come here and I've done 4 pi. Finish, and I'm not allowed to go any further. Ikra, is this clear? So my 4 solutions are x equals to pi on 6, 5 pi on 6. They were my first rotation solutions. And second solution is 13 pi on 6 and 17 pi on 6. This was my second rotation. Job done. Equation solved. Any dramas here? Anyone? I've granularized it to the layman's language, right? Is this okay? Everyone, right? Cool. Good job.